J-HAT 塾
We are told that we have 10 cards and they are numbered 1 to 10. And then we pick out 3 cards randomly every time. Okay, so the 3 cards are then assigned to the variables. The numbers on the cards are assigned to the variables X, Y, and Z. And such that whichever is the smallest in the cards, that number will be assigned to X, and the largest in the cards that we picked out would be assigned to Z, okay? And whatever is remaining, that means something in the middle between those two cards will be assigned Y. So we always know that every time we pick out 3 cards, the smallest we will call that X, the largest we're going to call it Z, and the middle we're going to call it Y, okay? Now, the question is, what is the probability that when you pick out 3 of those cards, three of the 10 cards, what is the probability that the smallest number, X, is 3 or less? Okay, so 3 or less, meaning 1, 2, or 3, right? So it it could be 1, 2, or 3, 1, 5, or 7, 2, 3, or 4. So the smallest must be less than 3. Okay, so what's the probability of that? Now, how are we going to do that? So we're going to count the ways. We're just going to count the ways such that we get a smallest number that is less than or equal to 3. So what are those numbers that are less than or equal to 3 that are possible from the cards? Well, we have a deck of cards with numbers 1 to 10. So the only numbers there that are less than or equal to 3 are actually 1, 2, and 3, okay? So we're just going to count all the ways, all the combinations of cards where the smallest number is either a 1, a 2, or a 3, okay? We just need to look at the smallest number in the set of 3 cards. Now, when we have that, we're also going to count the number of all possible combinations, okay? So it doesn't matter. We just want to count all the number of combinations of 3 cards that we can pick out of the 10 cards, okay? Because we do that because the probability is just the number of possible ways of the things that we're looking at divided by the number of all possible ways. So the first part here tells us the number of the ways that the event we're interested in is going to happen, okay? The event we're interested in, again, is such that the smallest of the 3 cards is a 3 or 2 or a 1, okay? So that's going to come in the numerator. And what will be in the denominator is just the total number of all possibilities when we pick out 3 cards out of a deck of 10, okay? So that's what we're interested in. So let's look at the first part, okay? How many ways can it be such that when we pick up 3 cards, the smallest number of those 3 cards is 1, 2, or 3? So to do this, let's actually look at the case when x equals 1, okay? X equals 2, and x equals 3. So let's start with x equals 1. If x equals 1, the only possibilities for y, okay, could be 2, 3, all up to 9. Okay, y cannot get a 1. Why? Because 1's already for x, right? And there's only 1 in that deck of 10 cards. Okay, so y could only be 2, 3, 4, 5, 6, 7, 8, 9. Now let's look at those cases one by one. What if y were 2? If y were 2, then z could only be 3, 4, 5, 6, 7, 8, 9, 10. So actually, you cannot have 10 here for y, because if y were 10, then z, which is the biggest of the 3, would exceed 10. So we also notice that. That's why we only have up to 9 for y to give 10 to z, okay? Now, what if y were 3? So the only possible values for z is 4 to 10, and so on. And up to when y is 9, then the only possible value for z is 10, okay? How many ways are those? Okay, the first one, we have, how many are these? 3, 4, 5, 6, 7, 8, 19. There are 8 of those, right? 3 to 10. This one's 7, and so on. And here we only have 1 way. Okay, so there are, if you add them all together, 8 plus 7 plus up until 1. So this is actually an arithmetic sequence. So arithmetic series. So you can just use that formula that you know. Okay, you look that up. It's just the number of terms divided by 2 times the first term plus the last term. And you get 36. That means there are 36 possible ways here. Okay, 36 possible ways to get an x that is 1. Okay, now what about the when the x is 2? Okay, the value of x is 2. So what's the only possible value for y? Well, y has to be 3 to 9. Okay, and again, we repeat the same process from earlier. We notice that when y is 3 and x is 2, then z could only be 4 to 10, right? And we do the same process from earlier, and then we arrive at this set of numbers again. We got 7 and so on, right? And again, we do the same arithmetic series sum, okay? And again, that's the number of terms. We have 7 divided by 2 times the first term 1 and the last term 7. And that gives us actually what, 28. Okay, so there are 28 ways when that x is equal to 2. Okay, now let's look at the last case. So actually, let's to make it a little bit clearer. Okay, let's get rid of this first 2 here because I crossed them out anyway. So let's just go ahead and look at the case when x is 3. Again, just like what we did in the previous two cases, the only possible case here is the only possible ways are when y equals 4 or 5 or 6 up to 9, which means z will have to be like these. Okay, and so when that's the case, then we can start counting again, just like we did here. And you know the drill. And if you do the same thing, you're going to get 21. Okay, now we can just add them up. We get 36 here, 28 and 21. You add them all up, that's going to be all the number of all cases, the number of all possible events where x is either a 1, a 2, or a 3. And remember, x is just the smallest card. You add them up, and you're going to get 85. Now, the second part of the problem is quite easy. We just need to know all the number of ways we can pick 3 cards out of a deck of 10. So that's just a combination. And we already know how this is done. This is 10 combination 3. Okay, so I'm just going to write that down here because we're not allowed to use a calculator on the test. So we got 10 factorial, 3 factorial, 10 minus 3 factorial. That's how you get the combination. And so it's going to look like this. Then 10 factorial, 7 factorial, they cancel. And you're left with 8, 9, and 10 above. And then 3 factorial is 3 times 2. Then 3 here cancels with the 9 here. So you just get 3. The 2 here cancels with the 8 here. You get 4. So 4 times 3 is 12 times 10. It's 120. Okay, and therefore the probability that the smallest card you get is 3 or below is 85 divided by 120. Okay, or if you want to reduce that, you can divide. They have a common factor of 5. Okay, so if you divide this by 5, you get 17. You divide this by 5, you get 24. And this is the answer we're looking for.
If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!